Hello, everyone. I'm Vijay Kumar. I'm a senior product manager with the Windows Platform and Experience team here at AWS, and I handle CloudWatch application insights.
Hi, my name is Jesus Yepes. I'm a software development manager at EC2, and I'm the manager of CloudWatch Application Insights.
Hello guys, my name is Zhongwei Gu. I'm a software development engineer working with Amazon. And currently I work on the product of CloudWatch Application Insights service. Today I'm going to go through a demo of using Application Insights to monitor customers' enterprise application. Thanks.
Hi, I'm Pallavi Sharma. I'm the product lead for Fleet Manager. I've been with AWS for over 4 years.
Hi, I'm Matthew Kurula, a senior software development engineer at EC2 and the technical lead for Fleet Manager remote desktop feature.
Hello, everyone, and thanks for joining episode 2 of our virtual workshop. In this episode, we'll be covering how to improve efficiency through monitoring and system administration. A quick look at the agenda. So we'll start off by getting to know Amazon CloudWatch Application Insights, and we'll actually get into a demo, and our colleagues will be showcasing how to monitor and troubleshoot .NET SQL servers on AWS. Following that, we'll segue into AWS Systems Manager, Fleet Manager, and that also includes a demo showcasing how to manage Windows instances with Fleet Manager. I just wanted to center ourselves in where we fit Applications Insights and Fleet Manager in the broader ecosystem. As you know, AWS has an array of tools and services to help you during each phase of the migration. We have many offerings to help during the assess and mobilize phases with many tools available to help support decision and planning. Once you begin the migration and you're running workloads in AWS, we offer a broad setup of capabilities for running and managing workloads. We offer several unique services that provide a simple visual management experience for Windows and other workloads. We also offer Windows integration with our larger ecosystem of AWS services. And these tools and services are designed to help modernize as well as migrate. So you have services such as Porting Assistant for .NET, which is an analysis tool that scans .NET framework applications, helps you port your applications to Linux faster. And there's also App2Container, which allows you to easily modernize your existing applications and standardize the deployment and operations through containers. Now, the Windows Platform and Experience team, in episode 1, you could have seen Image Builder and Launch Wizard. And in this episode today, we will be focusing on Application Insights and Fleet Manager. We'll start with Application Insights, and our team, myself, Vijay Kumar, and I'll be joined by Jesus and Janwei later. We'll go through first the challenges that many of you in large enterprises and other organizations face when it comes to monitoring. Like, you have everything running, and then how do you actually monitor the health and performance? What are the challenges there? And then we'll go a little bit about what we offer as a solution and why AWS Application Insights actually is a good choice for that particular use. Challenges are plenty. And you know that, we know that, and we have years of experience in understanding this, hearing from you, and implementing a lot of solutions. Some of these challenges are quite tangible, many of them are not. And it is the experience that we bring to the table that helps both the tangible and intangible challenges get solved. Monitoring the health and performance of workloads These aren't just done to keep executives happy. In fact, downtime actually costs money. But then even knowing where to begin is difficult for a lot of organizations. There are enterprises, IT departments who aren't familiar with the nuances of setting up cloud monitoring. It can be challenging to identify and set up metrics specific to workloads. You have to measure the right data for the application. You have to constantly think about scale and speed of deployment. And all of this, the change is difficult to keep up with. And you can't set up one at a time as well. Now, even if setup is automated, it's not clear how to apply this automation to cloud resources. Then the expense part of it, the tools themselves can be quite expensive. Licensing costs, duplication of tools, and overall resources consumption are just a few of the cost challenges. Many of the enterprises we've talked to have 3 or more non-AWS monitoring tools like SolarWinds or New Relic or AppDynamics, you name it. Now, these require their own licenses and all the costs of knowing and maintaining them as well. And there are quite a few issues when you have conflicts between teams while doing troubleshooting. So the whole enterprise observability setup and process can create those conflicts. Now, one of our customers in healthcare told us that they need to manage each layer of their application stack separately, and you can imagine the overhead that brings. If a simple thing like, somebody says that the app is slow, then there is a back and forth around, is it the network, is it the hard disk, is it the database, is it the application, and so on and so forth. So the need is slowly growing down a central and well-integrated service to help you give a single pane view of your application health across the board. So using and making sense out of this humongous operation data is not easy, and we are here to help. So talking about all of these challenges, what I would like to convey is that we understand the customer pain points for monitoring, and usually it is a brownfield. So figuring out what the customers are doing now and how they need to translate that to the cloud helps the customer navigate their cloud journey successfully for monitoring. So far, I've been talking about the what and the why. And to take you through the how, and more importantly, why us, I invite my colleagues, Jesus and John Way.
Thanks, Vijay. Let's dive a little bit on how applications its size can help. While it's great to have many resources and tools available, it's still a lot of work to get things set up. That's where CloudWatch Application Insights can help. The service was built with the enterprise that is starting their journey to monitoring in the cloud in mind. From our console, it provides a low-click user interface to quickly and easily set up the optimal telemetry metrics, alarms, and logs for your applications. It tailors things to your workload so you can be sure you are looking at and collecting the right things at the right time, but also gives you ease of use configuration update so you can fine-tune to your needs. For example, readjusting thresholds for an alarm, adding or removing metrics or components you want to monitor or not. Helps in not only setting up monitoring, but in choosing the best monitors for your applications. You can use resource groups or application registry to define the topology of the application you want to monitor. But if you want to do a quick onboarding, CloudWatch Application Insights can auto-discover resources and workloads that can be monitored and will set up everything at once. For power users or enterprise already using CloudFormation for infrastructure as a service, we also provide CloudFormation support. In summary, we bring more observability to enterprises, applications, and underlying resources. The automation helps to accelerate monitoring configuration and let our customers to focus on their specific needs. CloudWatch Application Insights leverage all the telemetry that can be configured and consumed in real time to detect problems and provide insights that helps with remediation on the problem. Once a problem is detected, you can see a series of automatic dashboards providing visibility into alarms, triggered exceptions in logs files, and events that might have contributed to the problem. We'll see more details on our demo. Finally, we provide support beyond Microsoft workloads, bringing also support for most used AWS resources and other enterprise workloads, and we keep adding more every year. Now, let's move to our demo for today, driven by Shenwei, one of our senior engineers. Thank you.
Yeah, thanks Vijay and Jesus for the in-depth walkthrough of CloudWatch Application Insights Service. Now let's see a demo. In this demo, we're gonna go through the monitoring journey on a very typical Windows workload with a .NET application running on 2 EC2 instances, backed by an application load balancer, and a Windows SQL Server on the backend to retrieve and persist data. The SQL Server also runs on another Windows EC2 instance. So with a traditional monitoring scenario, it could take customers a lot of effort to set up monitoring telemetries on even such a simple workload. For example, customers have to set alarms on key metrics such as CPU utilization and memory usage for their EC2 instances and the load balancer. Customer also has to collect SQL Server logs from the instance and view them line by line to capture the problems happening to their database. Of course, with the help of AWS services such as System Manager, Fleet Manager, customers can get easier access to visualize their instance interface and perform this monitoring setup. In today's demo, we're going to show with Application Insights service how it can help customers to automatically detect workload types, set up best monitors for their application resources, and also continuously analyze data for signs of problems with their enterprise workloads. Now let's see how Application Insights works. To use Application Insights service from AWS console, first, we need to open the CloudWatch console page. If we scroll down to the bottom, we can see a section showing all the problems detected on the applications already onboarded with Application Insights. On the left navigation panel, under Insights category, we can click Application Insights to go to the overview page of the service. On the overview page, customers can see their usage data summaries, such as their monitored assets, the telemetry is configured by Application Insights to monitor the applications, and also a summary of all the problems detected for the applications, with detailed analysis, such as top recurrent problems. Here in this account, we detect one problem for customer. To add an Application Insights application, customer can click Add an Application button. Application Insights supports multiple application types. Customer can either create an application using one of their resource groups, where they group all their infrastructure resources under a resource group, or create an application using all the resources within their AWS account. Here, prior to the demo, I have grouped all the resources provisioned for the sample workload under a resource group. So here I'm gonna create an application application size application on top of that resource group. Besides resource group, application size also has integrated with other APM services and the resource management services of AWS, such as Container Insights, Lambda Insights, and System Manager, Application Manager. These integration features enable customers to achieve one-click onboarding to application size monitoring. Application size also provides CloudFormation support, so customer can provision application size monitoring with their code as infrastructure solution. To add an application size application that monitors the resource provision in your CloudFormation stack, as simple as 5 lines of code to their CloudFormation stack template. Here is a quick example to do that. Okay, let's go back to onboard this application size application. On step 1 page, specify application details. We choose the resource group, which contains our application resources. It is named as application size resource group. On step 1, we can also specify, customer can also specify automatic monitoring of new resources, in which case application size will automatically pick up the new resources that was added to the application. Customer can also enable monitoring CloudWatch event, in which case the CloudWatch events of certain type of AWS resources, such as EC2, EBS, CodeDeploy, ECS, AWS Health, RDS, S3, and the AWS Step Function will be monitored. Customer can also choose to integrate the findings of application size with System Manager Ops Center in order to run automation solutions to mitigate the issue when problem happens on their application. Customer can also add tags to the application they create. When clicking Next, a backend workflow will be executed to analyze the application resource topology and detect workloads on application components. In this case, we have detected that a .NET web application has been running on the application load balancer, which has 2 nested EC2 instances. Also, application size found that there's a SQL Server process running on another EC2 instance. Now we go to step 3. On this page, customer can specify more component monitoring details. Without any customization, we have pre-filled these fields with the SQL Server logs to be monitored and the .NET Web front-end logs to be monitored. So here is a log path for your SQL Server. And on the last page, we can review the details of the application we're gonna create. After we click Submit button, the application will be created momentarily. Okay, after configuration process is done, application insights will kick off backend workflows to configure different monitoring agents, such as CloudWatch agent, Prometheus exporters, and to create CloudWatch telemetries, such as metric alarms and log groups. Then application insights backend will start ingesting data from these configured telemetries and continuously detect problems on customer applications. We can select one of the components within this application, click the Manage Monitoring page to see the detailed monitoring settings Application Insights has set up on this application component. So here we can see we automatically detect .NET web application running on this application load balancer, which has nested Windows EC2 instances. Application Insights is automatically monitoring the IIS logs on this .NET application. We also automatically monitor Windows events on the Windows instances nested in the load balancer. On the metrics level, we monitor metrics on load balancer level, EC2 instance level, and also the EBS volume level. We can see for EC2 instances, we are monitoring multiple CloudWatch infrastructure level metrics, such as CPU utilization. We're also monitoring performance monitor metrics on the Windows instance, such as processor and logical disk metrics. And we are also automatically monitoring .NET application related metrics. Customer has a freedom to change their monitoring settings. For example, they can remove and add any of the monitoring metrics. Customer can always come back and revisit and change their monitoring setting on their individual application component. By saving the configuration, your change will take effect. Okay, next, let's see some simple problems detected on the application. Prior to the session, I have manually generated multiple problems to the demo workload. For example, I have triggered multiple unhandleable 500 errors to the load balancer hosting the web application, like we show here. Also, on the Windows instance that is running the SQL Server, I reduced the allocated memory for the SQL Server to very low level, so all the executed queries resulted in insufficient memory errors. So traditionally, it would take a lot of effort to set up monitoring for such a complex workload and detect above problems. We will spend even more effort to continuously identify which component of the application is having issue. With application size, it's all handled automatically for you from end to end. And we will provide a centralized dashboard to capture all the ongoing problems happening on your complex application like this. Now let's go back to the application size console. We can see a high severity problem has been detected on the workload. We can see this high severity problem has a problem summary of SQL Server memory pressure. If we click into the summary, we can view the detailed problem dashboard. On the problem dashboard, we can view information such as a problem summary, the first occurrence time of the problem, the status of the problem, whether it's in progress, resolved, or it's a recurrent problem. We provide detailed insights to the problem, Here we capture the internal memory pressure issue on the SQL Server, and we notify customer the possible root cause of your problem and the potential solutions, how you can address the problem. Customer can give us feedback by clicking yes or no to the question whether the insights to this problem is useful. Underneath, we have a dashboard to capture all the ongoing issues happening on your application that we have grouped into this problem. Here we can see there were several 400 errors happening on the load balancer, together with some 500 errors that I just triggered on the load balancer. Also, application sites have automatically set up X-ray detection on your application, and we capture 100 of the requests sent to the load balancer just now falls into the 500 errors. Here in this section, we can see the errors we detect from the SQL Server logs on the EC2 instance. Here we can see the insufficient system memory issue on the SQL Server has been captured by application sites and showed on the problem dashboard. In another log group, we captured this 701 error happening on customer SQL Server, which for you who are familiar with SQL Server, this is an insufficient memory error. Okay, in today's demo, we went through how application sites can help customers to identify and set up key metrics, logs, and alarms across your application resources and technology stack, and how application sites will continuously monitor these telemetries to detect and correlate anomalies and errors for your application. That concludes the demo today. Thank you, guys.
Thank you. Once again, my name is Pallavi Sharma. I am the product lead for Systems Manager Fleet Manager, and I'm joined by Matthew Kuruvilla, Senior Software Engineer for Fleet Manager. So let's look at some of the most common IT management challenges that customers face. Today, organizations have to manage an increasingly diverse IT infrastructure that spans across cloud and on-premises environments. Managing these diverse hybrid environments can be complicated and costly, as customers usually have to use multiple tools and services from different vendors to perform even common and related management tasks. Navigating across multiple consoles and services leads to an inconsistent user experience and increased operational overhead. Many organizations are increasingly modernizing their workloads with Linux and open source software, which puts added burden of managing both Windows and Linux servers on system administrators. They often need to go through rigorous training to learn best practices and tooling for managing different types of machines. There is no easy way for operators to remotely connect to servers for troubleshooting and remediation. To address these challenges, we launched Fleet Manager, a capability in AWS Systems Manager that streamlines and scales your remote server management process. You can more easily manage servers running Windows, Linux, and Mac operating systems on Amazon EC2 or on-premises. With Fleet Manager, you can view and generate reports for your entire inventory of managed instances. It presents at-a-glance information about key instance properties such as image ID and patch status. If you want to focus only on a subset of instances, you have the ability to easily filter instances on the Fleet Manager console. You can drill down to individual servers to perform common troubleshooting tasks using a centralized visual interface. You can use Fleet Manager to view performance data about your instances in real time. You can quickly troubleshoot by viewing performance counters like CPU, memory, and disk utilization, along with network traffic. You can perform a variety of system administration tasks, including disk and file exploration, log management, Windows registry operations, and user management without needing to remotely connect to your virtual machines, saving your administrators time and effort. If you need to connect to your Windows machine, Fleet Manager also provides a simple browser-based means to access Windows servers using Remote Desktop Protocol, or RDP, with security protocols. You no longer need to install additional software, set up additional servers, or open direct inbound access to ports on the instance. It's that easy. RDP connections into Windows servers are established through a few simple steps in the console, providing access to your server or server-based application. With this capability, you can simultaneously open connections to multiple servers at once and access them from the same console, removing the need to switch back and forth between tabs. In addition to standard credential-based access, you can use AWS single sign-on and third-party identity providers such as Ping and Okta for a seamless one-click login experience. Now, I will hand it over to my colleague Matthew to walk us through a demonstration for Fleet Manager and its capabilities.
Thanks, Pallavi. This is Matthew Kuruvalla, a senior software development engineer at AWS and the tech lead for SSM Fleet Manager Remote Desktop Service. Today, I'm here to walk you through how to manage and troubleshoot Windows EC2 instances using SSM Fleet Manager. Fleet Manager is an SSM subservice that helps you troubleshoot SSM managed servers or nodes. These can be any server, Windows, Linux, or Mac, including on-premise machines. The only requirement is that the server should have SSM agent installed and running, and it should be able to access the SSM service endpoints. You can refer to this documentation page under Systems Manager to understand how to set up SSM managed EC2 instances. For the purpose of this demo, I have launched a few EC2 instances in my AWS account. These EC2 instances were launched from Amazon machine images vended out by AWS that already has SSM agent installed and running. In addition to that, I have created and attached an IAM instance profile to these EC2 instances. An IAM instance profile is an IAM role that has trusted entity as EC2 and can be attached to any server. This particular instance profile uses an existing AWS managed policy known as Amazon SSM Managed Instance Core that grants servers the permissions needed for core systems manager functionality. Fleet Manager doesn't need any inbound ports on the server to be open to the public or private networks, which makes it a very safe alternative to other management tools. This is a great benefit of using Fleet Manager for server administration. I have launched these EC2 instances in a default VPC. In case the customer has their instances in a private VPC, then they will need to do one more step of configuring VPC endpoints for SSM, EC2, and KMS. You can refer to this documentation page under Systems Manager to configure VPC endpoints. Fleet Manager uses SSM run command documents and SSM sessions manager services under the hood to give the user access to their servers. Some of the Fleet Manager tools require the KMS encryption to be enabled for it to work. You can use the KMS keys that you have or create new KMS keys for this purpose. Every Fleet Manager action, whether it is creating a directory or reading a file or the whole remote desktop access, can be controlled individually using IAM policies. You can create IAM policies that can give access to all the tools or to the specific tool action. All of these IAM policies are provided in the public documentation page under Fleet Manager. Here we have the Fleet Manager Administrator policy that has all the mutating and non-mutating actions provided in that. Also, you have the read-only features policy that just has the non-mutating actions in there. One thing to note here is that the IAM policies required for Fleet Manager Remote Desktop feature is different from other Fleet Manager tools and are provided in the documentation page specific to Fleet Manager Remote Desktop feature. This documentation has specific policies documented for standard users, also policy for connecting to instances with specific tags, as well as for AWS IAM Identity Center users or SSO users. Now, let me walk you through the Fleet Manager console. Given the time constraint, this is going to be an overview rather than a detailed explanation of every tool and feature. Here we have the Fleet Manager console that gives the centralized view of all managed instances. You can select instances in bulk and download this particular view as a report with all the required columns that you require. Also, you can do other bulk actions like connect with remote desktop, execute run command, patch nodes, add tags, etc. You can sort the instances by different properties like node name, platform, or even filter specific instance by giving those properties, by selecting the properties here and drilling down to a particular instance. Once you click on these instances, it'll take you to the Fleet Manager landing page for instances. In addition to the tools on the left side, this particular page also gives you an overview about the instance as well as tags, inventory associations, patch status, configuration compliance, etc. Fleet Manager is a useful tool for troubleshooting issues with servers. I would normally divide a troubleshooting use case into two sections: root cause identification and remediation. For root cause identification, we normally look into different logs like application logs or system event logs. File system is a tool that helps you browse through the different files in the system. For instance, I'm browsing through the different folders for a particular log. You can select the log file and preview it as a text that shows you the first 10,000 lines, or tail the file and preview the last few lines. You can also copy the path to the clipboard, delete the file, rename the file, cut, copy, paste the file in the system. In addition to that, you can delete a particular directory, create a directory also. Another step for root cause identification is to look into the system health metrics like CPU utilization, memory, etc. And performance counters is an excellent tool to showcase different resource consumptions like CPU utilization, disk input, output, network traffic, memory usage, etc. As a part of the troubleshooting, once we look into the overall system metrics, we tend to look into the processes tab. This tab gives you details about different processes on the system, and also how much does each of those processes consume different resources. You can sort the processes with different resources like CPU utilization, CPU usage, memory usage. Also search for a particular process, or if you want, you can terminate a process or a process tree. Also start a new process altogether. Another tool for root cause identification is the Windows event logs that helps you browse through the different Windows events and get the event details. The Windows registry tools helps you browse through the Windows registries, create a registry key or entry, also update and delete a registry key or entry. The users and groups tools helps you create a local user, a local group, delete a local user and a local group, or also add a particular user to a particular group. That's it from the Fleet Manager tools section. Now I want to showcase another feature that we launched in re:Invent 2021, which is the Fleet Manager remote desktop feature. You can connect to multiple instance type, just Windows, and connect to those instances using the remote desktop feature. You can view all those instances in the same screen and access those instances using 3 authentication methods. One is the user credentials, where the user has to put in their username and password. The second option is through key pair, where the customer can can upload their key pair that was used while launching the instance. And the third option is to use single sign-on if the customer's identity provider is already linked with AWS IAM Identity Center. In this particular case, the service creates a user on the instance and lets you log in with that. Here we can see all the 4 EC2 instances together in the same screen. You can just view one screen by clicking on that particular instance ID. You can set it to full screen mode and interact with it. You can end the session by clicking End Session under Actions menu. So that concludes today's demo about Fleet Manager. Thank you, everyone, and over to you, Pallavi.
Thanks, Matthew. So to summarize, Application Insights provides enhanced visibility into the health of your application and reduces mean time to resolve issues. Similarly, Fleet Manager streamlines and scales your remote server management process on AWS and on premises. You can drill down to individual servers to perform common troubleshooting and management tasks using a centralized visual interface. This slide also lists some additional resources for you to learn more about both these services. We've now come to a close of this episode. Please join us at re:Invent for a hands-on session to troubleshoot Windows instances with Fleet Manager. Thank you for tuning in today.